Hello, and welcome to this episode of Secondary Snacks. My name's Matt Ainscough, and I'm a secondary school maths teacher, and I also work with White Rose Maths as a maths specialist. In this episode, we'll be looking at the Year 7 block on developing geometric reasoning. Here is the overview of small steps for this block. In this session, we'll be focusing on one of these small steps to solve complex angle problems. This step builds on the previous steps of learning where students have looked at understanding and applying individual angle facts such as the sum of the angles on a straight line and the sum of the angles in a quadrilateral. Here is this step from the scheme of learning. Today I'll be mainly focusing on the second and third exemplar questions and using the key questions alongside them. In this small step, we consider angle problems where two or more angle facts are needed to be applied. It's expected that students are confident with recognizing and understanding some angle facts. However, they are probably at an embryonic stage with reasoning with the correct vocabulary. It's important to note that this reasoning can be completely verbal for now, as they will revisit this skill many times over the next few years in their learning. When two or more angle facts are present within a problem, it may be a cognitive overload for students when trying to find a missing angle. To reduce this cognitive demand, we can provide the answer and get students to focus on the reasoning, which can lead to a discussion about efficiency. This exemplar question does just that. Pause the video and have a quick read of the question. We can see that the model solution shows correct notation and reasoning throughout. We can see that angle TRU is 125 degrees because angles on a straight line sum to 180 degrees. Angle QRS is also 125 degrees because vertically opposite angles are equal. Therefore, angle QPS must be 75 degrees because angles in a quadrilateral sum to 360 degrees. However, we could have come to this solution instead by finding that QRS is 125 degrees because of angles on a straight line summing to 180 degrees. Therefore, this given solution is correct, but not as efficient. When promoting efficiency, most teachers tend to model the most efficient way to students. Rather than showing the most efficient way, purposefully exploring different approaches and paths enables students to see and appreciate efficiency, which can bring a greater depth of understanding. Here is a similar example that can get students thinking about multiple approaches. As well as access to worksheets in our premium subscription, we also provide each small step with a true or false question like this one. These are designed to be quick generators of discussion that everyone in the class can access. Pause the video to have a quick go and see what you think. Of course, the answer here is true. And as you can see, a detailed response as to why is provided. From this true or false question, you may then direct your students to discuss efficiency here. Here is another exemplar question from the small step. Pause the video and have a think about two things. What are the potential barriers students may encounter in this problem? And how would you start this problem? Let's address potential barriers. So far, students have only seen problems that require them to evaluate the size of a missing angle. Asking them to determine if a shape is a square sounds totally alien to this topic. Secondly, students can often make assumptions with geometric reasoning. I'm going to model one particular assumption. This angle must be 90 degrees since the angles on a straight line sum to 180 degrees. Therefore, the other angles in the shape must also be 90 degrees since this quadrilateral appears to have line symmetry, and since all of its side lengths are the same, I can determine that this quadrilateral must be a square. However, we have made the assumption that this is a straight line. This can highlight to students that we must start with the information that we are sure to be true, rather than what appears to be true. We can start the correct solution with this instead. These angles must be 74 degrees since an isosceles triangle has two equal base angles. We can then focus in on the point formed by the triangle and the quadrilateral and the angles that are present and known. We know therefore that the angles that sum around this point must be to 360. That means that this missing angle must be 88 degrees, determining that this quadrilateral is not a square. Exploring assumptions may help alleviate some of those common errors we see in geometrical reasoning. And when modelling, we can use the key questions that can act as a prompt for students, especially when it's their turn to give the reasoning. Here is a more challenging question from our premium resources. Again, it's another opportunity to interleave, in this case with algebra. The cloud icon indicates to students to give yourself some time to think about this problem, and teachers may want to encourage this too. Pause the video and have a think about the misconceptions this question may reveal. Students may just say the triangle is isosceles, but we need to be pedantic about which triangle is isosceles. Some may assume the orange triangle is, and come to the conclusion that x is 37 degrees. Others may say that the outer triangle is isosceles, but say that this angle is 48 degrees instead of it being correctly x plus 48 degrees. We can then use a bar model to represent the relationships of the angles within the isosceles triangle. You may also want to show the abstract representation alongside this. To reduce the cognitive overload here for students, you may want to encourage them to use their calculators when solving a problem like this. So we will subtract 37 from both sides to show that 2 lots of x plus 48 is equal to 143. We can divide into 2 equal parts to show that x plus 48 is equal to 71.5, and therefore determine that x must be 23.5 degrees. So here are the key points as we wrap up this secondary snack. Motivate efficiency by exploring inefficiency. Explore potential assumptions students may make. Use question prompts to promote mathematical talk. And be pedantic with correct vocabulary whilst reasoning. That comes to the end of our secondary snack. I hope that you've enjoyed it and I hope to see you again. Thank you very much.